Now, when I have something like a to the negative n, that means I can rewrite that as 1 over a to the n. Whenever you have a negative exponent, that just means take it from the numerator and put it in the denominator or vice versa. Now, a negative exponent is reciprocal, not a sign change, so be really careful about sticking extra negatives out. So we're going to rewrite each of these without a negative exponent and evaluate them if we can. So 10 to the negative 3 becomes 1 over 10 cubed, which is 1 over 1,000. For b, minus 5 to the negative 1, that negative sign is going to stay because it's outside. So this becomes minus 1/5. Now for c, this is 4/9 to the negative 2 is 1 over 4/9 squared, which is 1 over 16/81. And we invert and multiply, so we get 81 over 16. Now, we want to write each of these without negative exponents and evaluate them if we can. So the first one, m n to the negative 4, becomes m divided by n to the 4th. And mn to the negative 4th becomes 1 divided by mn to the 4th. And we're going to distribute that exponent to both terms. So it's 1 over m to the 4th, n to the 4th. When I have a to the m divided by a to the n, that's the same thing as a to the m minus n. You can do this when the bases are the same. And again, make sure you do them in correct order, numerator minus denominator. So let's see if we can simplify these. 15 to the 8th divided by 15 cubed is 15 to the 8 minus 3, or 15 to the 5th. Y to the 4th divided by y to the negative 9 is y to the 4 minus 9, which is y to the 13th. 35 r to the 6th divided by 25 r to the negative 4th is, we can go on and simplify out 5, and that becomes r to the 6 minus negative 4, so it's 7/5 r to the 10th. 34a to the 8th, b to the 11th, divided by 51a to the 12th, b to the 5th, becomes 34 over 51 times, let's breaking these up, we'll make this one easier, a to the 8th divided by a to the 12th, b to the 11th divided by b to the 5th. So this becomes 2/3 a to the 8 minus 12 times b, 11 minus 5, or 2/3 a to the negative 4th, b to the 6th. But we wanted it with positive exponents, so that's 2b to the 6th divided by 3a to the 4th. Now, here is a review of the exponent rules. Make sure you review them and know them. Let's simplify this expression, and we want to write the answers without negative exponents. So 5x cubed times parentheses 2 to the negative 1 x to the 4th, whole thing to the negative 3. The first thing you want to do is go on and distribute this negative 3 down. And so this becomes 5x cubed times 2 to the cubed, 4, or x to the negative 12. Now, you want to combine your x terms. So this becomes 5, x to the 3 minus 12 times 8. We can go to multiply that out. So this is 5, x to the negative 9 times 8, which is 40 divided by x to the 9th. For this one, let's do the same thing. Let's do the groupings. So 30 over 45 becomes 2/3. The r term becomes r to the 4th minus a negative 6 times s to the negative 9th minus 3. So we have 2/3 r to the 10th, s to the negative 12. Getting rid of negative exponents, we have 2r to the 10th divided by 3s to the 12th. Now this one's got enough like terms it's going to be a little confusing, but let's take our exponents and distribute them down. So we have 4 to the negative 2, b to the negative 6, 4 to the negative 3, b to the positive 3, 4 to the, that's 4 to the negative 1 times 4 to the negative 4, and b to the 3 times negative 4. So this becomes, collecting my 4's from my numerator together, this is 4 to the negative 2 times 4 to the negative 3, b to the negative 6 times b to the positive 3, and this is 4 to the 4th and b to the negative 12. Collecting our 4's and b's together, this is 4 to the negative 2 minus 3, b to the negative 6 plus 3, divided by 4 to the 4th, b to the negative 12. Simplifying this, I get 4 to the negative 5, b to the negative 3, 4 divided by 4 to the 4, b to the negative 12. Collecting all the terms now up in the numerator, I'm going to wind up with 4 to the negative 9, getting rid of negative exponents. I have b to the 9 divided by 4 to the 9. Whenever I talk about a to the 1 over n, if n is even and a is positive, it has to be positive, then this is the positive real number whose nth power is a. And we're going to call this the principal root. When a to the 1 over n is odd, then a to the 1 over m is going to be a positive or negative real number whose nth power is a. For all positive integers, 0 to any power, we're going to define to be 0. So let's evaluate each expression. 49 to the 1/2 is 7. Now for b, this negative sign is outside of this 1/2. So this is going to be minus 12. This is also outside. So it's going to be negative 12 again. 64 to the 1/6 is 2. Negative 64 to the 1/6, I can't take an even root, so this is not a real number. In this case, the negative is outside of the root, so this is negative 2. Now I can take the 1/3 power of an odd. This is negative 5. And this is outside, so this is going to be negative 4. When I have the expression a to the m divided by n, this is a to the 1 over n, whole thing to the mth power. Now, it doesn't actually matter which order you do these in and which order you wind up expanding or condensing them, depends a lot more upon the problem you're doing. So let's evaluate these. 81 to the 3/4. I don't really want to cube 81, but I can do the 4th root of it pretty easily. The 4th root is 3, so 3 cubed is 27. For this, I don't really want to cube 25, but I can square root 5 pretty easily. Square root of 25 is 5, so this is 125. The negative is outside, so I'm okay with that. It'll go along. I'm going to rewrite this as a square root of 4 to the 5th, which is minus 2 to the 5th, which is negative 32. Now, negative 64 squared to the cubed root. Now, the cubed root of negative 64 is negative 4, and negative 4 squared is 16. All right, the cubed root of 216 is 6, and 6 to the negative 2 is 1 over 6 squared, or 1 over 36. Now for f, I can't take the square root of 100, so this is not a real number. Remember the rules for exponents. Remember, you're going to have to know all of these. Now let's simplify these expressions. For the first one, let's combine the numerators. So 18 to the 1/2 plus 7/2 divided by 18 cubed. 1/2 plus 7/2 is 4/2, which is 4. So 18 to the 4 minus 3 is just 18. Now 10 to the 3/2 times 16 to the minus 3/4. We're going to want to do the square root of 100 cubed, the 4th root of 16 to the negative 3. So this is 10 cubed times 2 to the negative 3, which is 10 cubed divided by 2 cubed, which is 1,000 divided by 8, or 125. Now 4z to the 3/4 times 5z to the 2/5. We're going to multiply the 4 times the 5 and then add our exponents. So this becomes z to the 23 over 20. To simplify these, you're going to want to distribute the 2 and the 1/3 to each term. And now we're going to want to add the exponents for the m's in the numerator and the n's in the denominator so that we get 25 m to the 4th divided by n cubed. Now for the bottom one, we're going to want to distribute the y to the 3/7 to both terms, add the exponents, so we get y minus 5y squared. Now remember that if r is not 1, you cannot say that x plus y to the r is x to the r plus y to the r. And particularly, x plus y to the negative 1 is not 1 over x plus 1 over y. So let's factor out the least power variable that we can. So for the first term, we can pull out a 7y to the negative 5th, and we're left with 4 plus 3y cubed. For the second one, we can factor out 6n to the 1/3, and we're left with 3n minus 2. For the last one, we can factor out x plus 3 to the minus 2/5, and we're left with 1 plus x minus 3. And when we simplify this, we get x plus 3 to the minus 2/5 times negative 2 minus x. Now, we want to simplify this and write only positive exponents. So we're going to rewrite these with positive exponents. And now we see we have a complex fraction. So I got a common denominator for my numerator, common denominator for the denominator, and added the two fractions. Now we're going to multiply by the least common denominator, which is x squared y squared, divided by x squared y squared. When I distribute that, I get x times x plus y divided by y squared minus x squared. I see that I have a common term here when I factor the denominator, and it reduces to xy divided by y minus x.